Hello friends, today we'll discuss the uh, unit number 1 in the basic electrical in electronics engineering, the DC circuit, on which the topic is energy sources. Because without energy sources, we cannot have the electrical circuits. So before going in the details of DC circuits, we have to understand what is the different energy sources which can be utilized in the electrical circuits basically. The energy sources, the source that supplies active power to the network is the electrical source. The electrical source is of basically two type, namely independent sources and dependent sources. The independent sources means whether the voltage or current source depend on some other source or act independently. Means if the source is its magnitude or its value is independent of on any other quantity of the circuit, and it is known as a independent source. While if the source value is dependent on the some other element like a voltage of resistance or current in the resistance, then it will be known as a dependent sources. There is a two category of the energy source: direct source or DC source, and there is a alternate source. In the DC or direct current always flows in one direction, and its magnitude remains constant throughout time. Like here is a VT is going to be here. The magnitude of this particular voltage source is constant throughout time. Either it is zero or it is infinite. The magnitude will be same, and polarities also have a one direction, either is positive or other negative. While the alternating source or AC source, a current or voltage source is called alternating quantity if the it reverses periodically its direction, its magnitude undergoes a definite cycle of changes in definite interval of time. Like for 0 to 90, it is a maximum. From 90 to the 180, it is decreasing, becomes zero. It is a half cycle, and other is a negative cycle. It follows the same kind of pattern, and its value can be given by this equation Vm sin omega t, where Vm is a maximum value of the voltage that can be achieved during a cycle, either in positive or in negative. Direct voltage source will consider in this particular lecture. Here, direct voltage source can have a two category. One is the independent voltage source and current source, and other is a dependent voltage source and current source. Independent voltage source, the output characteristic of independent source are not dependent on any network variable such as current or voltage across any element. There are two types of the independent source. First one is the independent voltage source, this one, and second is the independent current source. These are the DC sources, and this is a symbol of AC voltage source, that is the independent. These are the value of current. IT means it is a variable in nature, and it is a DC. The magnitude as well as direction is keep on constant here. The ideal and practical voltage source independent. An ideal voltage source is one that maintains a constant terminal voltage no matter how much current is drawn from it. An ideal voltage source has a zero internal resistance, therefore, it would provide constant terminal voltage regardless of the value of load connected across it. Means if you connect a load like let's say a 1 ohm, or you connect a load of 1 mega ohm, the voltage across that particular element will be constant if that particular load is supported from a ideal voltage source. Let's consider here 12 volt voltage source, that is basically ideal voltage source. So its magnitude will always 12 volt. Either we connect 1 mega ohm or 1 kilo ohm or 1 ohm. In all three cases voltage across its terminal will be same, means 12 volt, 12 volt, 12 volt. The current can be changed, because if we connect a 1 mega ohm, current in microampere. If we connect a 1 kilo ohm, current in milliampere. And if we connect 1 ohm, the current the 12 ampere. Means we can change the current demand, but still the voltage across terminal will be constant. That is a property of a ideal voltage source. Ideal voltage source will have a constant voltage across its terminal, irrespective of the current supplied through its terminal. Means either of the current in the range of micro ohm, milliohm, or microampere, milliampere, or ampere. The voltage across its terminal will be constant. The practical voltage source. In the practice, there is no any ideal voltage source available. As we keep the load higher side, then the voltage start dropping across the terminal. Means in the previous case, as we are seeing, the load is either mega ohm, kilo ohm, or ohm, the voltages keep constant. But when the value of current drawn from the load is increasing, then the voltage across the terminal of a voltage source keep on decreasing. The real or non-ideal voltage source has a low but finite internal resistance, that is RINT, that causes its terminal voltage to decrease when the load current is increased, and vice versa. A real voltage source can be represented as an ideal voltage source in series with a resistance equal to the its resistance. Means there is a small difference between an ideal voltage source and a practical voltage source. Practical voltage source will have a series resistance, or it is known as the internal resistance of the source. Although value of the source resistance is very small, to be have in a proper manner. If the resistance is high, then there is a huge energy loss in the resistance itself. Here the value RL is a load resistance, and the IL is a load current, and E is the ideal voltage source. RINT is connected in series with the ideal voltage source, then it will become a real or practical voltage source. The value of RINT, the internal resistance of the voltage source, should be as small as possible. The voltage V naught can be considered but from this equation as a terminal voltage minus drop across this resistance, that is E minus IL RNT. The practical voltage source will become ideal one when V naught is equal to T, is equal to E. It is only possible when the RINT should be 0. If Because IL is a load current, and we don't have a control over the load current, because load can be anything. Hence we can control the value of RINT, that is the internal resistance of the source. Hence, during designing of the voltage source, RINT, or internal resistance of the voltage source, should be as small as possible. If we plot characteristic of a voltage source, that is a output voltage or terminal voltage, and that is load current. For the ideal voltage source, if the current is increasing, the voltage is not going to change, means the terminal voltage will be always constant. But for a practical one, where a resistance is connected in series with a voltage source, there is a drop of IL into RINT for each value of the load current. As the load current increases, the drop will increase, and the value of voltage, terminal voltage, will keep on uh, reducing. So that is a drop due to the internal resistance of the voltage source. Here it is very important to remember the point. As RINT becomes smaller, the real voltage source or practical voltage source more closely approaches to the ideal voltage source. As we have said earlier, if the RINT becomes 0, then practical voltage source will become ideal voltage source. Sometimes it is convenient when analyzing electrical circuit to assume that a real voltage source behave like a ideal voltage source. So thank you. We will discuss the next topic in the next lecture or presentation. Thank you.